Hello, welcome to today's episode. Today we are going to be installing Horin Geophysical Software produced by Horin Explore. So you come to the software, this is the commercial license. Right click on it. You click on Run as Administrator. You click Yes. Click Next. You accept the conditions, the terms and user license agreements. Click Next. Click on Next. Next. While you do this, the installation will be running on the background while you wait for it to install. Click on this, click on Finish. If you look on your screen, you'll see that it is requesting for a plugin. This is a plugin from Horin. This is the license activator from Horin Explore Geophysics. Their head office is in China. We in Nigeria, we are the representative GIS Grandmaster Company Limited. So if you want the commercial license and you're in Nigeria, you reach out to us at gisgrandmaster@gmail.com to get your license. But if you also want the free version where you test run the software, you can still reach out to us so that you have a free version where you test for some period of time to see how the software works. So I will insert this. Once I insert this, the commercial license will automatically load. Now that I've inserted the flash drive, I'll close this. I'll click Horin. Once I click on it, I'll run as administrator. Click Yes. It will launch. Before now, it was not able to launch because the dongle was not connected to the PC. The dongle is the license for the commercial software. So you can see this is your Horin Geophysical Software version 2024. So we want to create a new project. Go to Project, New Project. You can say project name. You can call this test data. Project group GIS Grandmaster Limited Ltd. Project handler Chigozie Ikechukwu. Remark testing. Browse to where I want the project to be saved. I'll go to Documents. I'll create a folder, Horin Explore Data Processing. I will double click on it. Then I'll click on Save. I think this is saving on my personal drive, which I don't want. But let me go to Downloads, Horin Tests. I'll save this as test data. Save. Okay. Once you have done that, this is your Horin Geophysics software. So in this tutorial, I want to show you how to extract your longitude, latitude, and your TMI value from a Geosoft Oasis Montaj grid file formats. Because Horin and Oasis Montaj are different software, most of the data sets acquired from Nigeria and other countries have their data structure in Geosoft formats. So I'm going to use a combination of QGIS and the required plugin to extract the XYZ value from a TMI grid, then import it into Horin Explore Geophysical Software. I will import it through the Excel formats. Import it as an Excel dataset. Because if you try to import this as let's say for instance I want to import my grid. If I want to import my grid, and go to gridding, load grid, and I'll browse to the grid location. Let's say for instance I go to downloads and I go to this sheet 291 Obudu. This is the TMI grid. It was developed, the file structure was developed using the Geosoft Oasis Montaj grid format. If I select it, click on open and say let's say new map, you see unsupported file formats. That unsupported formats, because if you look at this, it is still showing you grid file error. Because if you look at this, Horin data is coming as a .hr file structure, while Oasis Montaj is .grd. So to solve this problem, for you to be able to load Geosoft grid of aeromagnetics, gravity, or any data set that is structured to follow the Geosoft grid file formats, what you will do in that case is to download your QGIS. My QGIS is up and running. This is my QGIS. Once you download and install your QGIS is an open source software. The next thing you will do is to search for GRD loader. You just search for it under QGIS using this URL, https://plugins.qgis.org/plugins/grd_loader/. Once you do that, you'll be able to download the grid loader. You click on download latest, it is going to download the latest grid loader datasets plugin. So with this plugin, you are going to install this plugin. Once you download the plugin will download as a zip file. You can see it here, grd_loader 0.1.4. that's the version. So this is a grid file loader and it's in zip form. You can see it, compressed file, zip. So to load this data into Oasis Montaj, into QGIS, you come to QGIS, go to plugins, manage and install plugin. Now we are going to install from zip. So you select this option, browse to this folder location. Our downloaded file is under downloads. You can see grid grd_loader 0.1.4. Select the grid plugin, open it. Once it is connected to QGIS, you click on install plugin. You'll be given this prompt: installing a plugin from an untrusted source can harm your computer. Only continue if you receive the plugin from a source you trust. Continue, yes or no. This plugin was gotten from QGIS website, so we believe there is no harm from this data, from this plugin. Click on yes. You can see this notification here, plugin installed successfully. So we'll close this. Let's say we'll go back to plugin, manage, installed. You can see our install plugin grd_loader. You can see the icon. If you look at your toolbar, you see the icon here, GRD loader. Can close this. Now we want to launch our Oasis Montaj grade file structure for the aeromagnetic datasets that is unable to load in Horin Explore Geophysical Software. So you do this by clicking on this. You can see load grid file. You browse to your file location. Sheet 291 Obudu. This is the data from Nigeria. You can see the TMI grid. You select this grid, click on open. It will automatically extract the coordinate system of that dataset. We'll click on OK. It have loaded the data, although visually it's not showing an appealing colorama variation. We are not interested in colorama variation. Looking at the layer panel, you'll see the raster datasets. So what we are going to do in this case is we are going to export this. We are going to convert this raster to points, because for this raster to be created in the first place, it is an interpolation of points that gave rise to this raster. Because during data acquisition for aeromagnetic, at every specified interval, a sample point was collected containing the total magnetic intensity. So when interpolation was carried out either by kriging techniques or minimum curvature or any of the grading technique, we have this surface. So we want to extract the original point data. So to do that, what we'll do is you come to your processing tab, click on toolbox. As you click on toolbox, by your right panel, you will see the processing toolbox. Search for raster pixel to points. As you search for raster pixel to points, what this tool does is it will extract the points of each raster, of each pixel within this raster data. So I will double click on this raster layer. Under the parameter, the raster layer, you can browse, or the raster layer is already on the layer panel. It automatically selects it because that's the only item we have here. If we have other raster data sets, we can as well use this drop down to select the appropriate data sets we want to extract the points. Because extracting points from a raster data is like converting a raster to points. That's to get a vector data set. So the value name, since we know that this data is a TMI grade, we can say TMI underscore nanotesla. So it's going to create vector points. So we're going to click on run. Once you click on run, you can close this. If you look at your layer panel, you will see vector points. These are these points we have here. If you zoom in, you can see the points, various points. These points are the sampling points for our TMI grid. So this point is having the TMI value. So if you want to see the information from this point, you right click on this vector points, you go to your open attribute table. You see that your open attribute table is showing the TMI underscore nanotesla. You can see your values. Your values range from, see your data points. There are places we have no data. You can see NAN. So typically our data range is we have 305,765 data points or data sets. So what we are going to do next will be because within this point vector data, it has the coordinate, now the longitude and latitude. So what we are going to do to populate the longitude and latitude in this attribute table, we'll go to this open field calculator. Once you click open field calculator, we just type X. That's to get the longitude. Then under field type, we want it to be a decimal point, decimal number, numeric. Then for under the expression, because currently we are in the expression tab, can press shift $sign on your keyboard and type X. What this does is it automatically populates the longitude of those points. Click on apply. You can see the S field is created. We'll do the same thing for Y. That's the latitude. Then we'll apply. Field Y created successfully. Next, we are going to close this. So you can see here our longitude column and our latitude column has been populated. So what we are going to do next is we are going to export this table, this Excel table, these points as an Excel CSV file. We can close this, right click on the vector points, export, save feature as, we'll call it Obudu TMI. They will browse to folder location where we want it to be saved. Let's say download. And let me go to documents, go to Horin Explore data processing, save it there. The CRS, it's actually extracted the coordinate, that's coordinate reference system, from the raster, so that is why it is automatically populating in all the necessary field. We have the CRS. So what we'll do next is to click on OK. Oh, there is something I omitted. Right click on this, go to export, save feature as. The format, sometimes the format is not in CSV, so you have to select it, select CSV. Okay, what we exported is in .csv, so we are fine, so no need of repeating this process again. So we'll locate this. If I will click on this, it's going to launch where the data is. You can see it here, obudu_tmi. So what we are going to do now is we are going to import this in Horin Explore. So click on Horin. So next we'll go to database. We'll create a new database for this data we want to bring in. And browse to our folder. We want to save it. Go to documents, Horin Explore. We'll type Obudu TMI. So we'll click on save. We'll click on OK. So now we have our database created. Right click on the database. We are going to import ASCII data format. You can see under our downloads documents, we'll have, you can see the Obudu TMI. Select it, click open. You can see our data set TMI, X and Y. So I'm going to, it is separator. The separator in this case is data column and separated by comma or space. If you select this option, this is fixed width. Data column is separated by fixed width, but in our case it's separated by comma, and that's why it is CSV. Number of data that's greater than 10,000. The header row is in the header row is in number 1, the row 1. So data starts row number is 2, row 2, the data starts points. So the preview is going to show us like 500. So from here we'll have like 500. data points as if for the preview. So looking at this, the import wizard for the ASCII file, you can see that the separated by comma is selected because our data set is comma separated value, that's CSV. So everything is in order. We'll click on next. The first column, that's the TMI column, the column name TMI_n nanotesla is a data point. It's not a line data. It's not a line data. It's a data itself. So the data type is a value. Then data format, normal. The normal data format. It's not a date or year or hour. It's a normal data type. So for the X, that's the longitude. You can type _long to avoid confusion. And it's in UTM 32. WGS. I think this naming is too long. Let's say WGS UTM 32. Then we'll do the same thing for our latitude. This is latitude, WGS UTM 32. Then we'll click on finish. You can see from our Horin, we have successfully imported the TMI data. Let's say we want to grid this. We are going to go to gridding, then draw grid. Okay, we need to georeference this column, so we'll close this. So georeferences will come to coordinates, specify current coordinate of the column, the S coordinate, that's the longitude, specify it, the Y coordinate, that's the latitude, specify the Z property, that's the nanotesla. We'll click on OK. You'll see that now it has been specified, the Z variable, the X and the Y. So next we'll click on grading, draw grid. You can see here the input column we are using for the grading is the TMI nanotesla. The grading method, inverse distance weighting. So we are going to create the grid file name will be, let's browse to documents, Horin, and you can see it here, tmi.nanotesla, and grid file is in Horin grid. Save. Then the grid spacing, let's leave the default value, or we can leave this as 200. Or what we can still do to know the grid spacing is to come to QGIS, then use the measure tool to measure from point this to point this. You can see, I think let me cancel this, close. Let me redo the process again. Then this point to this point, almost 100 meters. So that's the sampling interval. Let me close this and measure from here to here, almost 100. So we are going to specify the grid spacing to 100. Then we'll click on OK. It's going to load the grid data. You can see the TMI grid giving us the color that we are looking for this particular data set. So this is how we can successfully extract the TMI grid, the XYZ values from Geosoft's data structure, like the Oasis Montaj data structure, because the data file was saved in that format. For most countries, Nigeria, the dataset, the aeromagnetics, the gravity, and other datasets was saved or stored in Geosoft Oasis Montaj data structure. So the seamless way to extract the XYZ value using an open source QGIS, like I showed in the first step, extracting, downloading the plugin, that's the GRD loader, installing the plugin, then importing our raster data into QGIS, then converting the raster to points, then creating the columns for longitude and latitude, and finally exporting the vector as a CSV file data. Next, we have to open our Horin if you have the commercial license, or if you have the dongle. Yeah, if you have the open license and the commercial license, you can follow the same step to successfully create your database, import your ASCII file, because the CSV is an ASCII file type, and finally you can grid using any of the grading techniques. And that's the end of this video. Thank you for watching.